Alright, hello and welcome back, and I think this is the 18th video that we've shot so far, and there's going to be a lot more because as you see we don't even have a robot yet. But I told you I was going to show you mapping functions, and it's really nice to know how to do. It allows you to automatically scale your data, and well, let's look at it. Let's look at it on the website. Let's jump up. No, that's not what I want over here. There we go. So, as a rule of thumb, by the way, if you have any questions and you can't figure it out from my video, generally speaking, if you just Google the term Arduino and then whatever we're talking about, for example, map, you're going to get a page from this collection of pages. And right now we're going to work with map. And map is a simple yet powerful tool. If I take the term map and in the parentheses, it's going to automatically take the value of whatever it is we're working with. For example, the input of the photoresistor. It's going to take the extremes of that input. So when we were playing with it with the serial, we saw it went from like 30 to about 900. In theory, we can actually go from 0 to 1023 with our chip. But actually, I'll probably start that way. I'll probably go from 0 to 1023, and we'll look at the output data and frame it from there. Okay? So, the value to be manipulated, the lowest you would expect that to be, to the highest that you expect that to be, and it's going to scale those numbers to a low to high. Okay? So, the output of this is going to be for example, the pulsing, the L293, we have to go between 0 and 255. Okay? So if I get a 1023 here, it's going to output a 255 here. Alright? If I have a 0 here, it's going to output a 0 here. So it scales it. Alright? So let's look at it. Let's just do it. And then I think it'll become more clear. Let's just do a new one because we're going to make this kind of short and sweet and fast. So let's see. This is a map function demo. Looks good. So we're going to need, we don't have to do it this way. I think we're going to want two variables. We're going to want the variable, the value from our photoresistor, and we're going to want a number to put that manipulated and framed number into. Okay, so let's create two variables. Let's create an integer. Well, I guess we've been calling it value. Let's go with value. All right, and this is going to be the data collected into the oh my god, I'm just having all kinds of problems. Okay, so that's the data collected in the photoresistor. We also want to have a variable that's going to be the output mapped function. Let's just call it mapped. This is going to be the number that gets framed from value. Okay, and our program is going to need, of course, our two favorite things. We need our setup, right? And of course, we're going to need our loop. Oops, I forgot to put those. Let me go back up there. I haven't even shown you these parentheses yet. What we can do with it, how we can hand data down the line. We should maybe do that real soon so you get an idea how to do that. Okay, to keep this simple, we're not going to run any motors at this time. Let's just output the data to the serial port. So let's make a serial port. And I'll shoot it at 9600. Alright, and let's do that statement where we kind of keep it held. So we'll do that while statement. Okay, we're going to hold it till the window is open. I suppose we could do the... We don't have... you know, I'm going to show you something. Normally, remember, I do a constant integer to set up the pin. Not to be lazy, but you don't have to, and I'll show you that right now. Let's get our data in. Value is equal to the analog read of what? Well, normally we would have put in pin or something like that. We're going to keep this simple. There's only one thing we're interested in. It's hooked up to pin A0. So we can actually just say that. Okay, so it's going to collect the data. From the photoresistor. Okay, that looks good. We should see that data. Let's take a look at it. Put it on a new line, and we're going to do value. Print the value. Okay, cool. I think we're ready to map. And I think we said that, well, there it is. The value that we're going to put that data in is called, or the variable is called mapped. And it is equal to, we're going to call the map function. See, it turns orange. It knows what's going on. And what we're going to map is the data that we collect in the value. Okay. We said that this being a 10-bit device, it's possible to go from 0 to 1023, but we might change that to fit it more optimally. But for the moment, let's go 0 to 1023. Okay, that's the biggest number we can possibly get. The smallest number out we want to do is the dead stop of the motors, so that would be pulsing it at 0. And the fastest we can possibly go is 255. How cool is that? Okay. Let's comment that one in a minute, because that's going to take me a bit to think about how I want to say that. Now, let's print that number. Except we don't want to do value, we want to do mapped. Probably a little delay would be nice. Oops. What do you say? Half a second? Delay. Boy, I just get my numbers all mixed up. Okay. Believe it or not, I think this will work, although this is going to be a little messy. Let's see what it looks like here. I'll show you what I mean. We're going to clean it up. Alright, Control Shift M. Oh, it's clearly working, but it's kind of hard to read. So let's clean this up. Let's make this easier to read. Let's have it say, before it puts out the value, let's do a instead of putting a new line, oh yeah, dyslexia is getting me bad today. Now let's put an original value. Original value is equal to that. So notice I didn't put an ln, so it's going to print this, and then it's going to print this on the same line, and then switch lines. And we'll do the same thing down here. Except here we want to have the mapped value. Okay. And then it would be nice to have a space in between these lines, and I think you remember how to do that. We just want to do another, we just want to have dead space. Oh, and this has to be a new one. Okay, let's see. It's going to collect the data. It's going to print out that data so we can understand it. Then it's going to map the data. It's going to assume an input anywhere between 0 and 1023. It's going to scale it so it outputs between 0 and 255. And then it's going to print that value of that scaled data and every other, or twice a second. Let's take a look. Cool. Okay, so right now in this pretty dark room, the original value is 440. Let's bring in a light. And you can see the original is dropping and the map value is dropping quite a bit. Okay, we'll pull it back out. Here's what I want to point out. Okay, the pulse width can only handle a number between 0 and 255. So the way we did it originally, 255, let's watch the original value. Okay, the original value is 255, right about there. Okay, it will go no faster than that, even though it can get a lot darker. And if it goes into complete darkness, alright, darker and darker and darker and darker and darker and darker. I'm gonna stop all light altogether. Oh, it does go to 1023. If I completely block it, it goes up to 255. So now the robot would move in full throttle as fast as it can because it's totally dark. And then it scales it in such a way that it's much more proportional. Okay? So you can see how this is going to be powerful to manipulate how we want our robot to behave in a mixed light situation. I'm going to end that here, and the next video we'll actually watch it move the motors. And I'll see you soon.